welcome back to this channel. Before we start with this video, let's recall back what we learned in last video. So in last video, we learned that alcohol can use to prepare alkenes. Besides from alcohol, haloalkane also can use to prepare alkene. However, the condition or the reagent are different. For alcohol, we use concentrated sulfuric acid with the hot condition. For haloalkane, we're going to use KOH in ethanol with the condition heat as well. So means that in last video, we can predict all the possibility of the alkenes. So now in this video, we're going to justify the major product based on the Saytzeff rule. Okay, and then also means that predict the major product of the elimination reaction. Basically, these two learning objectives are quite similar. Okay. Okay, so after we already prepared the alkenes, now we try to look at the Saytzeff rules. In elimination reaction, the alkene with more highly substituted. So the keyword here is highly substituted. Carbon-carbon double bond. So highly substituted is quite abstract for us. So when we look at what's the meaning of highly substituted carbon-carbon double bond, means that if the double bond there consists of greater number of alkyl group, will be the major and stable product. So now look at the example 1. We have the alcohol. So as we know, the OH will be removed and also the hydrogen next to the carbon. Okay, one hydrogen from next carbon. So we have two possibilities. Either we remove from this carbon or we remove from this carbon. So if we remove from the first carbon here, this is the product. If we remove from the second carbon, the product will be this. So now, we focus on the carbon-carbon double bond. This is the carbon with the double bond. So basically, there will have 4 groups. 1, 2, 3, and 4. So among these 4 groups, only 2 are alkyl groups. So we have 2 alkyl groups. The other one also, we focus on the carbon with the double bond. And every time each carbon with the double bond will always have 4 groups. 1 group, 2 groups, 3 groups, and 4 groups. So for this one, among these 4, only have 1 alkyl group. Even though this alkyl group have more number of carbon, but we still consider there is only 1 alkyl group. So based on the question here, greater number of alkyl group will be the major product. So that is why this compound is the major product. So if I want to name this major product, this product will not. This product is 2-butene is the major product. Okay, now let's look at example number 2 here. This is the haloalkane. So the chlorine will be removed, and then we can remove the hydrogen from this carbon. We also can remove the hydrogen from this carbon. Okay, so when this happens, okay, if the hydrogen removed from the carbon 1, the double bond will be formed at here. Okay, so this is if the hydrogen removed from carbon 1. So now we focus on the double bond, which is this carbon and this carbon. So for your information now here, we need to find out. Okay, this is the carbon, this is the carbon. So the carbon here now have 1, 2, 3. One more bond is hydrogen. And then this one, 1, 2, 3 means that one more bond is hydrogen. And then the fourth bond is here. The fourth bond is here. So for this one, we have 1 alkyl group, 2 alkyl group. Okay, so if the hydrogen is removed from second carbon here, so this is the possible product. So this is the carbon that we are going to focus. So this carbon now have 1, 2, 3, means that one more bond is hydrogen, 1 group, 2 group, and then here 1, 2, 3, 4, the third group and the fourth group. So we have 1 alkyl group, 2 alkyl group, and 3 alkyl group. Okay, so if based on here we have another one product, which I will not discuss with you further because later in the mechanism in next video we will learn more. But no worry, we still try to apply the Saytzeff rules. We focus to the carbon with the double bond, which is this. Okay, so for here we have this carbon have 4 bonds, 1, 2, 3, and 4. So 2 bonds are bonded to carbon, and then another 2 bonds are bonded to hydrogen. So this one also have 2 alkyl group. So among these 3, only we have one major product, which is the first one. Okay, so this is the major product. Please remark here, the one with the 3 alkyl group is the major product. Okay, now let's look at the tutorial question number 5. Using the Saytzeff rules, determine the most stable alkene. So first, we identify the carbon with the double bond. So from here, we know that there is 4 group at this carbon-carbon double bond. Each carbon have 2 groups. So this one with hydrogen, and then this one with 1 group is hydrogen, another 1 group is CH3. So based on these 4 groups, only 1 group is alkyl. 1 alkyl group. Now try to look at option B. So this is the carbon with the double bond. This one also carbon with the double bond. This carbon will have 2 CH3 attached to it. So 2 alkyl group here. And then this one will have 1 hydrogen and 1 methyl. So total is 3 alkyl group. 1, 2, and 3. Option C, this is the carbon with the double bond. This one also carbon with the double bond. 1 bond is bonded to hydrogen, 1 is bonded to CH3, similar with the carbon at the right hand side. So CH3, CH3, 2 alkyl group. While for the option D, these are the carbon-carbon double bond that we focus. And then when we look at carbon at the left hand side, consists of 2 alkyl group. Right hand side also have 2 alkyl group. So total we have 4 alkyl group. Okay. So means that 1, 3, 2, and 4 alkyl group is the greater number. Okay, greater number of alkyl group. So the answer is donkey. Now proceed to tutorial question number 7. Define the Saytzeff rule. So we will leave this one out because we already discussed in the previous slide. So number 7b, draw the structural formula and then name the major product and minor product for the following reaction. So when we see alcohol hydroxyl group with concentrated sulfuric acid heat, we know that the product will be alkenes. Okay, so definitely we know the OH will be removed. Then next we are going to remove hydrogen next to the hydroxyl group. Okay, so we have 3 possibilities. 1, 2, and 3. So now let's check if we remove the hydrogen from the carbon 1 here. So the product will be H3C, CH2, CH2. So and there will be CH because we remove one hydrogen and therefore double bond. CH3 at the top and it still remain at the right here. So based on this structure, the alkyl group is here. Okay, we highlight the carbon. So this is the carbon-carbon with the double bond. So one alkyl group, 2 alkyl group, and 3 alkyl group. Okay, we have 4 groups, but among maximum only we have 4 alkyl group. So among these 4, we only have 3 alkyl group. Okay, so now if the hydrogen is removed from carbon 2 here, so the product will be H3C, CH2, 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 we just made 10, and then C double bond, CH2 and CH3. Okay, so in this case again, the carbon with double bond is this one and this one. So now we also have 4 groups. 1 group, 2 group, 3 group, and 4 group. So among these 4, we have 1, 2 alkyl group. Okay, so we take here first, 1, 2, and 3. Okay, so another one is if the hydrogen is from this carbon number 3. So what will happen? So the product will be H3C, CH2, 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 C, CH3, and then double bond CH2. So again, for this alkene with the blue color in here also have 4 groups. 1, 2, 3, and 4 are hydrogen. So among these 4, again we have 1, 2. 2 are the alkyl group. Okay, so basically we know this is the major product because they have 3 alkyl group. Okay, then now we're going to, after we identify the major product, don't forget we need to name. So the longest carbon chain contains carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So once to here go up or go to the right are the same. So we just make it go to the right. So 6 carbon. So however, even though we have 6 carbon, but for this case, we are preferring number from the right to the left. Because if we from right to the left, carbon 1, carbon 2. So that means the double bond will be at lower number of carbon, similar with the substitute. So this carbon will known as, this alkene will known as 2-methyl 2-hexene. Okay, for this carbon, we will number from the top here 1, 2, 3, 4, 5, and 6. Okay, so for this one, the double bond is consist at the first carbon, and then substitute is at carbon number 2, so it's 2-methyl 1-hexene. Okay, so this one also same as we already know. Double bond need to be with the lower number, so this one we also will number from the right to the left. 1, 2, 3, 4, 5, 6. So the double bond is at the first carbon and the methyl group at the second group. So also 2-methyl 1-hexene. So basically the blue color one with the red color one, they are similar. Okay, so you just, that's why the answer here only have A and B. Okay, so you can label this is A because major product, and then you can label this as the B as the minor product. Let's proceed to tutorial question number 8. Draw the structural formula of alkene that would form where 2-chloro-3-methylpentane is subjected to dehydrohalogenation with sodium hydroxide in ethanol. Okay, so from here we know that we need to draw the 2-chloro-3-methylpentane. So start from the parent name as usual. Pentane has 5 carbon, 1, 2, 3, 4, and 5. 2-chloro-3-methyl. So complete this one, CH3, CH, CH, CH2, and CH3. So as we know, for sure this Cl will be removed. And then next we will remove another hydrogen from the left or from the right hand side here. So if we remove the hydrogen from the left hand side here, so the product will be CH2 double bond, CH, CH, CH3, CH2, and CH3. If the hydrogen is removed from the carbon at the right hand side here, then the product will be CH3, CH, double bond, CH3, C, and then bottom down here is the CH3, and then the right hand side here is CH2, CH3. Okay, for the right hand side here means that this hydrogen is removed. So if for the left hand side here means that one of the hydrogen removed, so become CH2 and then form double bond. Okay, so now we are going to check the number of alkyl group. So this is the carbon that we need to highlight. Carbon with the double bond. This one carbon with the double bond. So for the blue color one here, basically we only have one alkyl group, which is this one. Alkyl group, but the size is the big size. But for the green color one here, this is the alkyl group, this is the alkyl group, and this also the alkyl group. So in between these two alkene, the green color is the major product, and the blue color is the minor product. Just in case if you are the one who going to write the equation, don't forget here, at the arrow here, you need to put the heat sign, and then you will, because the question gives us sodium hydroxide, so we will put NaOH and then ethanol. So again, don't forget the side product, which is hydrogen, and also the Cl. So in this video, we already learned how to predict which is the major product and which is the minor product. So in the next video, we are going to learn the mechanism, how the haloalkane break the bond and form alkene. So see you in next video. Bye.